Stars are massive, luminous balls of gas that emit energy in the form of light and other forms of electromagnetic radiation, and are the building blocks of galaxies like our own Milky Way. Stars are the most common objects in the universe and are formed from clouds of gas and dust in space. The gas that makes up a star is primarily hydrogen and helium, which are the two lightest elements in the periodic table. Stars produce their energy through nuclear fusion, which is the process of combining atomic nuclei to form heavier elements. The energy released during this process causes the star to shine brightly and emit radiation in the form of light and other forms of electromagnetic radiation. The size and temperature of a star determine its color, luminosity, and lifespan. Stars range in size from small, cool red dwarfs that can live for trillions of years to massive, hot blue giants that burn out in just a few million years. Stars have played a critical role in shaping the evolution of the universe, and their study helps us to understand the processes that have led to the formation of galaxies, planetary systems, and the elements that make up all matter. The study of stars is called astrophysics. Stars can be classified based on several properties, including their temperature, size, and luminosity. One commonly used classification system for stars is the Morgan-Keenan (MK) system, also known as the spectral classification system. This system is based on the star's temperature and the elements present in its spectrum. The spectral classification system groups stars into 7 main classes, from hottest to coolest. O blue and very hot stars. B blue-white and hot stars. A white and hot stars. F yellow-white and moderate temperature stars. G yellow and moderate temperature stars, like our Sun. K orange and cool stars. M red and very cool stars. Each class is then subdivided into 10 subclasses, numbered from 0 to 9, with 0 being the hottest and 9 being the coolest within each class. For example, our Sun is classified as a G2 star, meaning it is a yellow dwarf of moderate temperature. Luminosity is another important factor in star classification, with brighter stars being classified as more luminous than fainter stars. Stars can also be classified based on their size. The size of a star is typically measured in terms of its radius, or its physical size, compared to the radius of our Sun. There are 3 categories of stars based on size. Dwarfs, these are small stars that have radii less than or equal to 1.5 times the radius of our Sun. Dwarfs can be further classified into several subcategories, including main sequence stars, white dwarfs, and brown dwarfs. Main sequence stars, like our Sun, are stars that are actively fusing hydrogen into helium in their cores, while white dwarfs are stars that have exhausted their nuclear fuel and have collapsed into a small, dense object. Brown dwarfs, on the other hand, are objects that are too small to sustain nuclear fusion in their cores and are often referred to as failed stars. Giants, these are stars that have radii between 1.5 and 10 times the radius of our Sun. Giants are typically much brighter and more massive than dwarf stars and have exhausted their core hydrogen fuel, causing their outer layers to expand. Supergiants, these are the largest stars, with radii more than 10 times that of our Sun. Supergiants are also the most massive and luminous stars, and they burn through their nuclear fuel at a much faster rate than other types of stars. Overall, the size of a star has a significant impact on its evolution and ultimate fate, with larger stars typically having shorter lifespans and more violent endings than smaller stars. Stars can explode in different ways, depending on their mass and stage of evolution. The 2 main types of stellar explosions are supernovae and novae. Supernovae are the most powerful explosions in the universe, occurring when a star with at least 8 times the mass of our Sun runs out of nuclear fuel in its core. As the star's core collapses under its own gravity, it becomes incredibly dense and hot, triggering a runaway fusion reaction that releases an enormous amount of energy. This explosion causes the outer layers of the star to be blasted into space at high speeds, creating a supernova remnant that can be observed for centuries. Novae, on the other hand, are less powerful explosions that occur in binary star systems where a white dwarf star is orbiting a companion star. The white dwarf accretes material from its companion, and when enough material accumulates on its surface, it undergoes a runaway fusion reaction that causes a sudden increase in brightness. The explosion ejects some of the accumulated material into space, creating a temporary brightening of the system. Stars can also explode in other ways, such as in gamma-ray bursts or X-ray bursts, which occur in very specific and rare conditions. Overall, stars explode because they have exhausted their nuclear fuel and can no longer generate enough pressure and heat to resist their own gravitational collapse. This can trigger a runaway fusion reaction or other explosive events that cause the star to be blasted apart, releasing a tremendous amount of energy and creating some of the most spectacular events in the universe. The universe is the totality of all matter, energy, space, and time that exists. It includes all the galaxies, stars, planets, and other celestial bodies, as well as the vast regions of empty space between them. The universe is believed to be approximately 13.8 billion years old and is thought to have begun with the Big Bang, a massive explosion that initiated the expansion of the universe. Since then, the universe has continued to expand and evolve, with galaxies and stars forming and dying, and with various physical processes shaping the large-scale structure of the cosmos. The study of the universe and its properties is a major focus of modern astronomy and cosmology, and has led to many important discoveries and advances in our understanding of the nature and origins of the universe. The evolution of the universe refers to the changes that have taken place in the universe over time, from its earliest moments to the present day. The current scientific understanding of the evolution of the universe is based on observations and data from a range of sources, including cosmological models, the cosmic microwave background radiation, and the properties and behavior of galaxies and other cosmic objects. The current widely accepted theory of the evolution of the universe is the Big Bang theory, which suggests that the universe began with a massive explosion approximately 13.8 billion years ago. After the Big Bang, the universe underwent a period of rapid expansion known as cosmic inflation, during which it grew from a singularity to its current size and structure. Over time, galaxies and other structures began to form, driven by the force of gravity. These structures continue to evolve and change, with galaxies merging and stars being born and dying. The universe is also expanding, with galaxies moving away from each other at increasingly faster rates due to the influence of dark energy. As the universe has evolved, it has also undergone a series of phase transitions, with different types of particles and forces becoming dominant at different times. These transitions have included the formation of atoms, the emergence of light, and the development of the strong and weak nuclear forces. Overall, the study of the evolution of the universe is a major area of research in cosmology and astrophysics, and has led to many important discoveries and insights into the nature and origins of the universe.